Okay, so for this video, we are going to talk about section 4.3, which is graphing the tangent and cotangent functions. So we're first going to talk about how to graph the tangent function. And to do this, we need to look at this using the identity that tangent x is actually equal to the sine x function divided by the cosine x function. So what that tells us is that tangent will be undefined whenever cosine x is equal to 0. All right. And when does that happen? So going back to our unit circle, we can picture all the x coordinates. Whenever the x coordinates are 0, we're 0 up here, we're 0 down here. So that would be at all of the pi half multiples, actually the odd multiples of pi over 2. So this would be at pi over 2, 3 pi over 2, 5 pi over 2, 7, 9, and so on, or in the negative direction, negative pi halves, negative 3 pi halves, and so on. And the way that we can write that is it would be 2n plus 1 times pi over 2. So whenever we get an angle of any sort of odd multiple pi over 2, the tangent function is going to be undefined. So at every value where this is true, where that x value is one of those 2n plus 1 times pi halves, the graph has what's called a vertical asymptote. All right, what that is, it's essentially, I visualize this as like a vertical wall that the function can never touch. It'll get infinitely close to it, but it will never actually touch it. So we're going to actually graph this, and I'll show you exactly what I mean when I say that it'll never actually touch. So we're going to fill out one period of the tangent function. So to do that, the values that we're going to use, we're actually going to start at negative pi halves and then go to negative pi over 4, then to 0, pi over 4, and pi over 2. And that actually, just those values right there will cover an entire period of the tangent function. So what are we going to get when we plug in negative pi halves? So the tangent at negative pi over 2 is really the sine at negative pi over 2 divided by the cosine at negative pi over 2. But again, any angle that has a pi over 2, cosine is 0, and it makes the whole thing undefined. Okay? If we use pi over 4 now, if we think of the unit circle, remember all the pi over 4 multiples, sine and cosine are the same thing. We're in quadrant 4, so we would get a negative 1 for our tangent function there. At 0, sine at 0 is going to be 0. Cosine at 0 is 1. So when we plug it into sine over cosine, we're going to get 0, which is 0 divided by 1. Pi over 4, we're back to where sine and cosine are the same thing. And then again, any pi over 2 multiple, we're undefined because cosine is 0 there. Okay, so what I can put on my graph right now is I'm going to put those asymptotes that I was talking about. So vertical asymptotes, anytime you see a pi over 2 multiple. And this is kind of how we denote that on the graph. I have another one at, let's see, at negative 3 pi over 2 over here. All right. So what I can graph right now, the values that I do know, I have negative 1, a y value of negative 1 at negative pi over 4, 0, 0. And when the angle is pi over 4, the value of the function is 1. So the question now is what's happening right around those asymptotes? We got to think a little bit about what's actually going on. So what we can say is as x is approaching or getting closer and closer to pi over 2, so we say as x is approaching pi over 2, then the cosine function is getting closer and closer to 0. Right? So we can picture the unit circle as our x values, as our angle gets closer and closer to pi over 2, we know that the cosine function, because the x coordinate is getting closer and closer to 0. So what does that mean is happening to tangent? Well, I'm going to write down here what's happening to tangent. So if you have the sine x on top, cosine on bottom, and the cosine is just getting closer and closer and closer to 0 as you keep getting a closer and closer and closer to an angle of pi halves. So what that ends up meaning is you get a really, really tiny number. And if you think about what happens when you divide by a really, really, really small number, what you get is a really, really large number. And how large? Well, there's really no bound, because how tiny can this number get? It can get infinitely close to zero, so it can get infinitely small, which makes this infinitely large. So tangent actually goes to infinity in that case. So as we approach zero in the cosine function, the tangent function is approaching infinity. Now, on the opposite side of that, as we approach negative pi halves, well, all of our tangent values down here, since we're in quadrant 4, are going to be negative. So what we have going on here is as the x is approaching negative pi halves, cosine x again is getting closer and closer to 0. But what we have, again, a really tiny number giving a really large number. But what we have is a negative value going on, because look what quadrant we're in. We're in quadrant 4. And in quadrant 4, cosine is positive, but sine is negative. So our value for tangent would always be negative. So we get negative infinity. All right. So to put this all together, this says as we start to, so we're starting at 0, 0, and as we start to approach pi halves, the tangent function just keeps going up and up and up and up, and there's really no bound to what happens. So it just goes up and up and up forever. It hits this asymptote, which it will never touch. It's like an invisible wall that it can never hit. And then we have the same thing happening to the left. We go to negative infinity. So the y values just never stop decreasing at that point. That's one full period. So we've just covered one period. And after that, the tangent function just repeats itself. So you have a 0 at pi, you have 1 at 5 pi over 4, you have negative 1 at 3 pi over 4, and then it repeats itself just like that. And then the same thing would be happening over to the left. You'd have a 1 here repeating, going up to infinity, a negative 1 here, and then going down to negative infinity. So look, something like that. Oops. Sorry, that should be a little bit nicer. Okay, this one looks better. So just copy that one. Okay, so real quick, let's write down domain, range, and the period for the tangent function. So the domain, way we're going to write that in set notation is it's the x values. So domain is always the x values, such that x is not one of those odd multiples of pi over 2. The range is anything, because it goes to infinity and negative infinity. So we say it's all real numbers, or the set notation for that is a big bold R. And then the period is pi, because this distance right here from negative pi halves to pi halves completed one period, that's pi. And more generally, if we have a tangent bx, the period would be pi divided by b. All right, so somewhat similar to what we had going on with sine and cosine, except sine was 2 pi instead of just pi for the period. All right, so we're going to take that same idea and we're going to graph the cotangent function, which is very, very similar. So same kind of idea here, because the only difference now is which function is in the numerator and which is in the denominator. So the only difference between cotangent and tangent is you just switch the cosine and the sine. So it's now cotangent has the cosine on top, and this will be undefined whenever the sine function is 0. Right? If you have equal to 0 down here, you're dividing by 0, which is not possible in mathematics, so it's undefined in that case. And this happens at all of the not even, but all of the integer multiples of pi, or how we'd write that is n times pi. So as whenever sine is always 0 at any time, if you're on the unit circle, and anytime you are at the x-axis, right? This is when y is 0 for sine. So these are my y equals 0 values. And that's going to happen at 0, at pi, at 2 pi, at 3 pi, so on and so on, or in the negative direction at negative pi, negative 2 pi, negative 3 pi, so on, so on, so on. So every time we hit a pi, our cotangent graph will be undefined. So graphing it's going to be very, very similar, because it's going to have those asymptotes at all of the in this case, integer multiples. Where we're going to start for this period is actually at 0 instead of at negative pi halves. We're going to pi fourths, pi halves, 3 pi fourths, and then at pi. And this should cover one period of the cotangent. So the cotangent of 0 is the cosine of 0 over the sine of 0. That is undefined because we know that the sine of 0 is 0. So that's no good. At pi over 4, again, they're exactly the same thing. So we're at 1. At pi halves, this is where sine is 1, but cosine is 0. So we hit 0. At 3 pi over 4, we're now in the second quadrant. So the cotangent is going to be negative. And then at pi, again, all those pi multiples, we're back to 0. So our one period will start at 0 and have an asymptote, no good. We have another one at pi, and this should cover one period right here. Same reasoning that we just did previously. That's 0. This will be, negative 1 at 3 pi over 4, positive 1 at pi over 4. And kind of by that same reasoning, as you're approaching 0, that cotangent's going to go up to infinity, and then it's going to work its way down to negative infinity to the right. All right, and then that would be what repeats. So that's one period, and then that just kind of keeps happening over and over and over. Got 1, got negative 1. So we've got infinity, it flattens out, and then goes down to negative infinity like that. Same thing happening to the left. At pi halves, you have a 0 because that's where your cosine is 0. We've got 1, negative 1, and again, flattens out and then shoots down to negative infinity like that. All right, so the way we're going to write our domain this time is it's all of the x values, but this time x cannot equal an integer multiple of pi. So n times pi, 1 times pi, 2 times pi, 3 times pi, 4 times so on, so on, so on, and the negatives as well. The range, again, is all real numbers, just like it was with tangent. And then again, our period is pi, or if we had a little bit more general, our period would be pi over b for some angle. Okay. All right, so we're going to do one example with negative tangent of 2x. So we're going to graph that. Let's note that this is reflected over the x-axis. That has to do with that negative value right there. Our period is pi over 2. This is pi over b, where that is our b value in our general form for our functions. So we've basically just split the period in half. So if we remember, the way that we graphed tangent originally was we started at negative pi halves. So we want to split that in half, and instead we're going to start at pi fourths. And then we're going to work our way down to negative pi eighths to 0, pi eighths, and pi over 4. And to evaluate these, as you're getting used to this, just plug it in. Right? So we're going to get the negative tangent of 2 times negative pi over 4. That turns into the negative tangent of negative pi halves. But we know that anytime we're at pi halves with tangent, that's no good because that's when our cosine is 0. And whenever cosine is 0 and tangent is sine x over cosine x. So whenever that cosine is 0, we're no good. We're undefined. Okay. Now I'll do one more. We'll do the 2 times negative pi over 8. So that turns into the tangent of negative pi over 4. And at negative pi over 4, we're in that fourth quadrant, and it's negative 1. And then at 0, we should be at 0. That's sine. And we're back to 1, and then we're undefined again. So the way that this is going to look, we'll just draw one period of it. This will be my negative pi over 4, negative pi over 8, pi over 4, pi over 8, pi over 8, pi over 4. Then our asymptotes right here. I did that on both sides. Should be pi over 4 on the left. And here's the difference.